Hey Josh, and solve this problem from the 10th edition of the Fundamentals of Physics
Extended
by
edition.
extend, extended edition by Halliday and Resnick,
And Walker.
Walker.
So here in figure 545, a black hole mass 5 kilograms here is pulled along a horizontal frictionless floor by a cord. I think he meant a massless cord that exerts a force of magnitude F equals 12 newtons an angle of 25 degrees. What's the magnitude of the black's acceleration? The force magnitude F is slowly increased. What's the value just before the block is lifted completely off the floor? So just imagine you're pulling a block and then you just tug it very hard. Of course, it's going to lift off the ground eventually. So what's the force? The very bare minimum force is to lift it off the ground. And
Okay.
what is the magnitude of the block's acceleration just before it's lifted off the floor? Let's start with the free body diagram. Uh, so there we go. There's the force. And then of course there's a normal force because it's on the ground. And there's the x and y direction, it's theta, and there's a gravitational force mg. This figure number 1. So A, F cosine theta is equal to max. This is from Newton's second law, of course. Since this is the x component of the force F. So we're going to use cosine and ax. So F sine theta plus Fn, which is the normal force, minus mg. These are all along the y-axis. Was may. So the mass times its acceleration along the y-axis. This is the total, the net force along the y-axis. So here, acceleration y is 0. Why? Because it's on the ground. If it's going to lift off, then there will be an acceleration in the y direction, but there isn't any because it's still on the floor. That's what we assume. It doesn't lift off the ground. Yes, see, for now. For now, ay will be 0. So ax using equation number 1 equals f cos theta over m, which is equal to 12 newtons cosine 25 over 5 kilograms. Now that we have substituted, we can find both ax and ay. So ax is 2.18 meters per second squared. The magnitude of the block acceleration is 2.18 meters per second squared. B. Fn, so the normal force is equal to 0. Because there's no more floor. For the block, it's already in space. So imagine that there is no more floor for the block because there's a layer of air already. So now there's no more normal force, and still, why is there still no acceleration of y? Because it just lifted off the floor. It's not yet accelerating. Thus f sine theta is equal to mg. Why? Because of course the force along the y-axis is only the normal. It's only the force along the y-axis, and the net force along the y-axis only the force exerted on the block in the y-axis, and its gravitational pull exerted on the object. Those are the only forces. So now F is equal to mg over sine theta. So now we can substitute 5 kilograms over 9.8 meters per second squared over sine 25 degrees is equal to 116 newtons. Okay, so this is equation number 7. The minimum value of the forces needed for the block to just be lifted is 160 newtons. So from 4, 6, and 7, we can conclude this. Ax is equal to f cosine theta over m. So it's already listed. It's already listed here. Number 6, AX equal to F cos theta over M, which is equal to 160 newtons cosine 25 over 5.00 kilograms. We can now calculate this, and it shows up as 21.0 meters per second squared. AY is still 0. So the total acceleration is using the Pythagorean theory. Pythagorean theorem. Using the Pythagorean theorem, we have a square root of ax squared plus ay squared. They are the two sides of the triangle. Just imagine it. So actually, there's a figure here. So they're the two sides of the triangle. So the total acceleration is the hypotenuse. So this is equal to square root of ax squared, because there's no acceleration in the y direction. So it's still 21.0 meters per second squared. So that's A. Magnitude of the block's acceleration is 2.18 meters per second squared. And then for B, the minimum value of the force needed for the block to just be lifted is 116 newtons. And finally, for C, the acceleration magnitude just before the block is just lifted is 21.0 meters per second squared. That's it.
That's it. Nice.
Thanks for
Thanks
watching.
for watching.